I am Pawan Kumar Sakya, PhD scholar from IIT Kanpur. I am the TA for the course of Element of Solar Energy Conversion. So there will be two discussion hours on Friday and Saturday from 6 p.m. to 7 p.m. On Saturday, the session will be taken by me. So today I will discuss some problems and if you have any doubt then you can ask me anytime. So let's start with a simple problem that we have solved in our UG course. So I want to try. I want to say that if you people will try, then it will be useful for you. So I give you 2 minutes. Try this problem and let me know that what answers you got. Okay. Then if you are not able to solve, then I will do this. Okay. Is that fine with you guys? Okay. Has anyone got the answer? Then you can write your answer in comment. Okay, so now I will do this problem. So the problem is the thermal radiation of 600 unit falls on a body with zero point 0.2 absorptivity and 0.7 transmissivity as shown in the figure below. Calculate the reflected, absorbed and transmitted radiation. So first we can see that the given data are the absorptivity is 0.2, transmissivity is 0.7 and the radiation given as 600 unit. So the question asked what is the reflected and absorbed and transmitted radiation. So as we know that the reflected, first we need to calculate the reflectivity to calculate the reflected radiation. So as we know that the total radiation falls on will either reflected, absorbed or transmitted. Thus the absorptivity, transmissivity and the reflectivity sum of all these will be 1. Thus, if we put the value of alpha that is 0.2 and transmissivity is 0.7, then we can calculate the reflectivity at rho equal to 0.1. From here, we can calculate the reflected radiation. So, reflected radiation will be GR equal to rho and the total radiation that is falls on the body. So, it will be 0.1 into 600, that will be 60 unit. Then second, the question asked about the absorbed radiation. So the absorbed radiation will be alpha equal to alpha times G. That will be 0.2 into 600. That will be 120 units. The third, the question asked the transmitted radiation. Tau into G, that will be 0.7 into 600. That will be 420 unit. Thus the answer will be 60, 120 and 420 unit. Now I want to discuss some more things that what is reflected radiation and what is absorbed radiation, what is transmitted in the body. So if suppose 600 units radiation is falling on this body, then this body will transmit some radiation to the atmosphere. That will be our GT, that we have calculated as 420 units. Sorry, my mistake. It will be the reflected radiation, GR, that will be 60 unit. Okay, then the body absorbs some radiation, that is called the absorbed radiation, that will be GA, and that value is equal to 120 units that we have calculated. And what will be the transmitted radiation? Transmit radiation will be the radiation that transmitted through the body. Suppose 600 units is falling on this body, then the radiation that will be transmitted through this body will be the GT, that is we have calculated as 420 unit. If anyone have any problem or doubt in this question, then you can ask. Else I will forward to the next problem. So I think there is not any doubt. So now I will forward to the second problem. The second problem is that for a black body at a temperature of 5800 Kelvin, peak emission occurs at a wavelength of 0.5 micrometer. For a black body at temperature 1000 Kelvin, the peak emission will occur at. So there are four options: 2.9 micrometer, 4.9 micrometer, 8.9 and 20.9 micrometer. So I give you 1 minute. If you want to try, then you can try. Other than I will solve this problem. And if you get the answer, then you can write your answer on the comment. Can anyone tell how we can approach to this problem? You can unmute yourself also. Okay, so now I will discuss this problem. So, okay. So this problem is also from our UG course that you have solved in the heat transfer course in the radiation chapter. So first I would like to discuss some more things about the laws that we will use in this problem. So if you have gone through the radiation chapter, then you have read about the Planck's law, where it has been shown that the irradiation and the relation between the irradiation with the wavelength. So this is the curve that is drawn for a particular temperature. So suppose the temperature is T1 and the peak of this radiation occurs at some lambda 1. Now what will happen if we increase this temperature or decrease this temperature? Suppose we are decreasing the temperature. So with the decrease in temperature, the curve's peak shifts towards the right. Thus, its the wavelength increases. And this one is for temperature T2. The similar happens continuously as we decrease more temperature. So suppose this one is for T3, and the peak, its peak occurs at lambda 3. So if we join the peak points, then we will find that this peak curve will follow a hyperbola that will be lambda m equal to constant. Sorry, lambda m dot t equal to constant, where lambda m is the maximum wavelength at which the peak occurs. Thus, from this law, lambda m dot t equal to constant is called Wien's displacement law. That you have, I think you are aware about that. So here T1 is greater than T2 is greater than T3, and lambda 1 is less than lambda 2, and similarly lambda 3. Thus, from this formula, now we can solve our problem. For the first case, the given temperature is 5800 and the maximum peak occurs at a wavelength of 0.5. So from the above formula, we can write that lambda 1 T1 equal to lambda 2 T2. So for the first case, lambda 1 is 0.5, whereas T1 is 0.5800 Kelvin, equal to the lambda 2 has been asked, and the temperature for this case is given as 1000 Kelvin. Thus, if we solve this, then we will find that lambda 2 equal to 2.9 micrometer. So the answer of this problem will be the first one, 2.9. So if anyone have any doubt in this problem, then you can ask. This one is hyperbola. Hello, Charan, are you there? Actually, I want to know that whether are you guys able to unmute yourself or not. Can anyone unmute yourself and answer? Are you able to hear me?
Yes, sir.
Okay, fine. That's fine. Okay, so now I will move to the next problem. So till now, I have just taken some few basics problem that you have already aware. Now I will move to the problems that will be the related to this four solar energy elements of solar energy conversion. So the problem is the solid angle subtended by the sun to the observer on the earth. So if anyone want to answer, then he or she can unmute and can answer. Okay, so I think till now you guys have not seen the lectures. Okay, that is fine. So I will try to show you that how we calculate this angle. So If you will see the lectures, then you will be able to answer all these problems. So suppose this is the sphere that represents our Earth, and this one is the Sun. As we know that the Sun and Earth centers distance around 1.495 into 10 to the power 11 meters. Okay, so the question asks that the solid angle subtended by the Sun to the observer on the Earth. So the question basically asks, suppose this is the observer, and then what will be the angle subtended by the Sun to this observer? So this is the alpha that we want to calculate. Okay, so suppose this is a tangent and we connect this with the center of the Sun. Then as we aware that the diameter of the Sun is around 1.39 into 10 to the power 9 meter. That is 110 times to the Earth. Okay, and this is the tangent that is drawn on the Sun. So this will be the 90-degree angle, and then we can take this angle. Suppose this one is O, and this one is observer O, and this is the O dash Suns, and this one is any point A. So if we take this triangle in triangle O dash AO, then we can calculate this one will be the alpha by 2 from symmetry. Then we can say that sine alpha by 2 will be equal to O dash A divided by O dash O. As we know that this is the distance 1.495 into 10 to the power 11 from the center to center distance. But as there is very few or minor change in the angle due to this distance from the Earth for the Earth radius. So for this case, we are neglecting this one. Okay. So sine alpha by 2 will be equal to O dash A divided by O dash O. So that will be equal to O dash A will be 1.39 into 10 to the power 9 divided by 2. It will be divided by O dash O, that will be 1.495 into 10 to the power 11. This one is sine alpha by 2. From this, if we calculate, then we will find that this alpha equal to 0.5. Then we will find that this sine alpha by 2 will be equal to 0.26636. So this, from here we can calculate the alpha equal to 632 minutes after multiplying with 60. From here we will calculate the alpha value in degree. Then after multiplying with 60, we will find that the alpha value will be 32 minutes. Thus the answer will be the D, 32 minutes. Okay. If anyone has any doubt, then he or she can ask. Okay, so let's move to the next problem, that is explain the solar constant. Yes. Okay, so from the above problem, we will see that the distance between the Earth and center distance is 1.495 into 10 to the power 11. There's this one actually does our Earth rotates around the Sun in a elliptical path. Thus, the distance between the Sun and Earth changes with time. So this one is the mean Sun Earth distance, and there will be variation around plus minus 1.7% with this distance. So based on this, we can say that there will be some mean distance between the Earth and the Sun. So now we will see that what will be the solar constant. So suppose this is the Earth and this is the atmosphere. Then if we take a plane that is perpendicular to the path perpendicular to the sun radiation. So solar constant is basically the average radiation intensity of solar radiation outside the Earth's atmosphere at the mean sun Earth distance. Okay, so I will write the definition. The average radiation intensity of solar radiation outside the Earth at the mean sun Earth distance. As I have told you that the distance between the Earth and Sun changes with the time. That's why this term, the mean Sun Earth distance, is important for this definition. So we will see in the next problem that how the radiation changes with time. Okay. So in for this problem we can see that the solar constant value, that is constant, and nowadays it has been defined as 1367 watt per meter square. Okay, if anyone want to ask anything, then he or she can go. Okay, so let's go to the next problem. The next problem is the solar constant and extraterrestrial radiation are related as with the exponential function, cosine function, sinusoidal function, or tangential. So I think it will be on this digit. Okay, so the relation between the solar constant. So first you have to understand that what is the extraterrestrial radiation. So the term terrestrial related to the Earth, whereas extra is related to the outside. So the extraterrestrial radiation is the radiation that is falling outside the atmosphere at any distance. Solar constant was for a particular position, that is mean sun earth distance, whereas this extraterrestrial radiation is for any distance. Thus from here we can say that this extraterrestrial radiation value will change with time, and how it will change, that we will see. So the formula for this we denote this extraterrestrial radiation as ION, where N is normal and O relate to the outside this atmosphere. So this ION is equal to ISC 1 plus 0.033 cos 360 N divided by 365. So this is the relation between the ION and ISC. So from here we can see that the relation is related with the cosine function. So the answer will be B. Further, I will also explain some few more things about this relation. So from this we can see that the relation, if we draw this curve, then we can see. So suppose this is the time of January and this one is December, and in this axis there is radiation intensity. So suppose this one is 1320 and this one is 1420. Then from the above formula we can see that ISC is constant, that is around 1360. So this one is 1360. All the values are in watt per meter square. Then we will see that so this one is the cosine function, and this is ION. From here you can see that this ION value changes with the time. So throughout the year the value of extraterrestrial radiation changes. So if you have any doubt in this problem, then you can ask. Hello Dinesh, are you there? Okay. So if anyone have any doubt, then you can ask. Else I will move to the next problem. Okay, so let's go to the next problem. So the next problem is find. Okay, so Prince is asking that can we get the slides after session? Yeah, you will get this slide. Also, you will get this video recorded lectures. The link will be given after this recorded lectures. Okay. So the next problem is find the terrestrial normal irradiation on 30th July 2022. So as from the above problem we have seen the relation between the ISC and ION. So the ION is equal to ISC 1 plus 0.033 cos 360n. I forgot to discuss that what is this n. So now I will discuss that what is this n. So basically the n is the number of days. Number of day starting from the first Jan. So for suppose if we are calculating the ION for the 1st January, then the n will be 1. Similarly, if we are calculating it for 10th Feb, then it will be there will be 31 days in the January month. Then we are asking for 10th Feb, so it will be 31 plus 10, that will be 41. Okay. So in this problem, it has been asked to calculate the ION for the 30th July. So first we have to calculate that what will be the n for this 30th July date. So we will see that. So this is the month Jan, Feb, March, April, May, June and July. So in the July it has been asked on 30th July, so there will be 30 for this July days. Earlier there will be 31 days in Jan, 28 Feb, then again 31 March, 13 for April, 31 May and 30 for July. And if we will calculate, then n will be the sum of all these numbers. So the sum will be around 211. Okay. So if we put this value on this formula, in this formula ION equal to ISC, the ISC value is also given as 1367. So we can calculate ION is equal to 1367, 1 plus 0.033 cos 360 into 211 divided by 365. And if you will solve this, then you will find that the ION value is 1327.21. That is watt per meter square. Thus the answer for this problem will be B, as the nearest answer is 1327. Okay. So anyone has any doubt in this problem? Also, if you have any doubt related to the theory that I am discussing, relating with the questions, then you can also ask that. Okay. Okay, so let's move to the next problem. So the next problem is has been asked the explain the revolution of the earth around the sun throughout the year with its four important positions. So this is the figure that has been drawn, and the question is asking about the positions that is shown in the figure. So first, as we know that our this is our earth that revolves around the sun in elliptical path. Also, the earth rotates in the anti-clockwise direction around the sun. So okay, so now I will discuss that how the seasons changes and how the days happen in the throughout the year. So as we know that our earth is tilted towards the sun. So suppose this is the axis of earth, that is we can see that is not perpendicular to the plane of orbit. So this one is tilted. Okay, then so from here we can see that if we will take this position as most right side, then we can see that the north pole is tilted towards the sun. Thus from here we can see that in the southern side there will be cold. Okay, so from here we can see that there will be summer in this time. So what will be the time for this? That I will say that it will be 21st June, and it will called the summer solstice. Summer solstice. Okay, so from here we can see that this one is our north side that is tilted toward the sun. So there will be summer in northern hemisphere, whereas there will be winter in sorry there will be winter in southern hemisphere. Okay, so with the time the earth revolves around the sun, and on 21st September it reaches to a position where there is not any tilt towards the sun. So on these days, the 21st September, also the similar conditions happen when it returns to this position. This one happens on 21st March. So these two positions where day and night are equal. Okay, and these positions are called. This one is called autumnal equinox, whereas this one is called spring equinox. Okay, so now the remaining fourth position, it will occurs on 21st December. Okay, and this one is called the winter solstice. So from the figure we can see that the southern hemisphere is tilted towards the sun. So on at this time there will be, also we can say that the winter will be on winter in northern hemisphere, whereas summer in southern hemisphere. Okay. Okay. Okay, so these are the four positions of the earth that is important for us to know, and what are the and how the axis, also we can say that the axis where that is tilted towards the sun, that one is called declination angle, and its value is around 23.45 degree, for your knowledge. Okay, so now if you have any doubt till now, then you can ask. Okay, I want to know that how many have seen the lectures that is provided on the swam portal. Does anyone have seen? Okay, okay, Prakash. So if you have any doubt in the lecture or in these problems that I have solved, then you can ask me. Okay, so I think there is not any doubt. Okay, that is fine. So I think that's all for today. That I want to solve these problems with you guys, and now you will see that the first assignment that will be related to these two lectures will be easier to solve. Okay. Also, I want to say that if you have any doubt at any time, then you can write me a mail on my mail ID, or you can ask me on forum. Okay. Okay, so that's all for today. I think no one has any doubt. So okay, fine. So now I will end this discussion hour. Okay. So let's see you on next Saturday, 6 p.m. to 7 p.m. Okay. Thank you.